Hello everyone, welcome to a new class in object orientation with design patterns, and in this opportunity we're going to be talking about the command pattern. Now, the command pattern is going to be another one of the behavioral design patterns of this module. And just as a bit of a recap, a behavioral pattern is one that is going to help us design the behavior of a program. So it's going to help us design how a system or a program is going to respond to a particular input. So in this case, the command pattern is particularly good when it comes to achieve loose coupling between a request response kind of model. So if you have a system where you send a request on some sort of query and you expect a response back from the system. Now, the way this works is that the request that has come to the system gets sent to an object called the invoker. This invoker object is going to encapsulate the request in another object called the command object. And finally, that command object is going to be passed to another object called the receiver object. Now let's see that in a graphic, because these are a lot of sending and receiving and invoker, so it might be quite confusing. So let's take a look at the graphic that we have on the right hand side, where I get the request, the invoker receives the request, then the invoker passes the request to the command object, and then the command object will pass the request to the receiver. So it's always in that sequence. Now, from a class diagram point of view, the invoker uses a command object, and the command object will use a receiver object. Now, notice that in this case, we have that my command 1 is implementing the command interface. That is because I can potentially have multiple commands for different activities that I can have. So we'll see an example in a second. But at the end of the day, all the different activities that I will have, they need to all implement the interface command, because that is the one that has the execute method to execute the actual command. Now, in this opportunity, I think you'll be delighted to hear that I'm not going to ask you to code anything. In this opportunity, I'm going to give you the full code, and what we're going to do is to try to understand how this code is working. So let's see an example. So when I have a file system, I can do things differently for different file systems. So I can have a Windows file system or a Unix file system. So Unix would be Linux or Mac, but it's two different types of file system, and things are done differently for these different file systems. Well, this file system would be my receiver. So depending on the file system in which I'm sitting, I'm going to execute different commands in different ways. Now, in this case, I have implemented a file system utility that is going to help me define which one of the file system I am working on at the moment. So the code that I have given you, Moodle, is going to be able to identify what sort of file system you have in your own system once you run the code. So I have also created a file system interface, and I have two concrete classes, one for Windows and one for Unix. So let's take a look at that bit of code. So in my receiver package of the code that I have given you, I have a file system receiver interface, and there I have the three kind of things that I can do, that I have defined what I can do with these file systems. So I can open a file, I can write a file, or I can close a file. Now, the implementation of those methods for each type of file system is going to be different. So let's take, for example, a look at the Windows file system receiver. Well, the Windows file system receivers implement the file system receiver interface, and of course, it must implement the unimplemented method. In this case, open file, write file, and close file. Just for the sake of showing how these work, I'm just putting system.out.println in there, but it could be any implementation. It could be whatever is relevant to a Windows file system to open a file, or to write a file, or to close a file. In this case, I'm saying opening file in Windows OS. Now, likewise, for the Unix file system, the same thing. The implementation is different though, because the way I implement the open file command in a Windows environment is different it's different to the way that I would do it in a Unix environment. Now, I have created a little utility here that will help me create an instance of one of the file system depending on the file system that I have in my program, depending on the file system that I'm actually running this on. So, something that I would like you to try to do is to identify which is the pattern, the creational pattern that I'm implementing in this class. I'm not going to tell you what it is because it's not part of what the main core of this class, but this is a kind of nice little touch in there. There is a creational pattern implemented in here. Try to identify which one it is. Now, let's take a look now at the second part of my command pattern. Now, the first part was to define who is my receiver. The next part would be to define my command. So let's take a look at the command. Now, in the command, just as we saw in the class diagram, the command interface has an execute method. And of course, I have three possible commands. So I can open a file command, I can write a file command, or I can close a file command. Let's take a look at each one of them. Now, what is going to happen in here is that each one of the commands will implement the command interface that will guarantee that it will have an execute method in there. Now, who is going to execute or how is going to be executed? Well, this command is going to contain a receiver. And this is what I was saying. This is what we saw in the class when we were in the class diagram. So we can see that each one of the concrete command will have an instance of the receiver class. And it could be any of the receivers really. So as long as it is implementing the receiver, in this case, the file system receiver interface. So that instance is going to come in the constructor, is defined in a member class, in the class member attribute. And in my execute method, all I need to go is go to the file system and close the file. I know that for any file system, a close file method is going to be there. Now, the thing is that this file system is going to be different for different implementations. So if you're running this program in Unix, this will run the close file system for Unix. But if you're running this program in Windows, this will run the close file system method for Windows. Now, the open file and the write file are the same logic. So what is happening in here is exactly the same thing as before. It's just that for the open file command, the method that I'm calling is the open file as opposed to the close file. So in the case of the write file, exactly the same story. I just receive a file system, which is going to be my receiver. And on that receiver, I'm going to call the corresponding method. Now, what about the invoker? The invoker is the one that is going to actually wrap up the command, and from the command is going to call the execute. This is going to be the bridge between my command and my client. So let's take a look at how that works from the client point of view. From the client point of view, the first thing I need to do is to identify the file system that I'm working on. So this is going to identify who is my receiver. So for that, I'm using the utility that I've created, and hopefully you have identified which one was the creational design pattern used for the identification of this. Now, once I have got the file system receiver, then I can create my command. And in this case, well, I'm creating one instance of each one of them. I'm creating a command for open file, a command for write file, and a command for close file. So once I get the command and the file system, then I can do the link between them. How? With my invoker. So in this case, my invoker, which I have called file, is going to be a new file invoker, and it will receive the command. So as you can see, the command is wrapping up the receiver, and the invoker is wrapping up the command. So I have like a 3-layer onion in here. So once I have the invoker, I can say invoker.execute. Now remember, invoker.execute is going to go to the command and run the method execute. And in the command, depending on the command that I'm running, whether it is closing, writing, or opening, that execute method is going to go to the file system and call the corresponding method. So if it is the close command, it's going to call the close file. If it is the open command, it's going to call the open file. And if it is the write command, then it's going to call the write file. Now, the important thing here is that we understand this onion-like structure that is happening here. Now, let's run this to make sure that I'm not lying to you. So that it is. In my case, because I'm running this program in a Windows computer, it's identifying Windows and is calling the command for Windows, opening, writing, and closing for Windows. So that's the instance that has been created. Now, if you are running this program in Linux or Mac, you will see opening file in Unix OS as opposed to Windows, because the program is solid and robust enough to identify who is your underlying operating system and call the corresponding methods. Now, what implications do we have for this command? And what would be some pros and cons? Well, the command is the core of the design pattern, and it defines a contract from the implementation. So in the command, I am deciding what kind of things I'm able to do. So I will have concrete implementation of the command interface for each one of the things that I'm actually able to do in my system. So the receiver implementation is going to be separate from the command implementation. So my receiver implementation is adjusting that command for different type of environments. And the command implementation classes will choose the method to invoke on a receiver object. So in the case of the command implementation, depending on each one of the command I am instantiating, I am going to be calling different methods in the receiver. Now the invoker will forward the request from the client to the command object. So the invoker is the one that is going to finally say execute. The client is responsible to instantiate appropriate command and receiver implementations and then associate them. As we saw in the program, the client is creating not only the instance of the file system, which is my receiver, it's also creating the instance of the command that I want to execute. And the client is also responsible for instantiating the invoker object. Now, the invoker object, I only have one. Now, my receivers and my commands, I will have multiples. So the invoker is the easy part because I just pass in the command to the invoker. Now, this is very easily extensible because you just add new classes and new actions to the command and new actions to the receiver. So it's easy to expand. One of the drawbacks is that the code gets very big and it's actually confusing. This is one of the reasons in this instance, I'm not asking you to code it yourself. I'm giving you the full code of this particular pattern. It can get quite big and quite messy and quite complicated. So that would be one of the biggest disadvantages of this pattern. Well, guys, thank you very much for watching. I hope you liked it and I'll see you in the next one.